And just so that people know what we're talking about before we get into this, I always do something called the pinch test, and everybody can do it. You can do it. You can do it right now, Richard. Yeah. You just take the skin on the back of your hand and you pinch it between your thumb and your forefinger and you lift it up. And then you hold it there and then you let it go. Okay. Now, the thing is, in a young person, it'll snap right back, right? In an older guy like me, it kind of goes down slowly. This is not collagen, as a lot of people are told that collagen makes your skin flexible. That's not true. Collagen gives your skin strength and firmness, but it doesn't give it flexibility. It's this elastic fiber that's woven in between the collagen that actually gives it flexibility. And the important thing is this: it's not just in your skin. It's in more than 30 of your organs. It's in your arteries. It's essential for everything in your body to expand and contract.
And we are live for another episode of Being Human. I'm delighted to say I'm here with Douglas Mulhall. He is the author of the best-selling book, Discovering the Nature of Longevity, Restoring the Heart and Body by Targeting Hidden Stress. For 30 years, he's been creating products that are healthy for people and the environment. He's worked with especially European governments to improve the environment, and he has got a particular interest in Elastin. And before Douglas reached out to me regarding the show, I'd never heard of that Elastin. I sort of vaguely had a sense of what it might be, but I'd never actually heard that term. And I've been around wellness, well-being for over a decade now. So I was surprising that was new to me. And so got curious, and I'm delighted that we now have Douglas on the show. So a warm welcome, and maybe we should start with that, Elastin, Douglas.
Richard, thanks so much for having me. And yes, you're absolutely right. Most people have never heard of Elastin or its importance. And I'll say right off the bat that it is kind of like a Dr. Jekyll and Mr. Hyde substance in our body, because we can't live without it. It drives every move we make, every breath we take. And at the same time, it ages us as we get older, and ultimately actually leads to our death. So it is this two sides of the same coin. And just so that people know what we're talking about before we get into this, I always do something called the pinch test, and everybody can do it. You can do it. You can do it right now, Richard. Yeah. So what you do is you just take the skin on the back of your hand and you pinch it between your thumb and your forefinger and you lift it up, and then you hold it there and then you let it go. Okay. Now, the thing is, in a young person, it'll snap right back, right? In an older guy like me, it kind of goes down slowly. I don't know what happened to you.
It was sort of somewhat. I can't claim that it snapped back, but that way.
Well, that's pretty good though. And so this is not collagen, as a lot of people are told that collagen makes your skin flexible. That's not true. Collagen gives your skin strength and firmness, but it doesn't give it flexibility. It's this elastic fiber that's woven in between the collagen that actually gives it flexibility. And the important thing is this: it's not just in your skin. It's in more than 30 of your organs. It's in your arteries. It's essential for everything in your body to expand and contract. All of your ligaments have it. So every time you move, you're using elastin fiber. And so you can't see, you can't pee, you can't breathe, you can't pump blood, you can't have sex, and you can't give birth without elastin fiber, because that's what allows all of your tissue to expand and contract. Now, there's something else that's really important about elastin. It is part of a network in the body that connects everything. Everything. This combination of elastin and collagen is woven together into what is commonly referred to as the fascia. It's also called the extracellular matrix. It's the space between your cells that actually holds your cells in place. And this system actually runs through the entire body. It's the biggest system in your body. It's actually was just recently named the 80th organ, which is called the interstitium. So you can see how incredibly important elastin is, and yet most people have never heard of it. And the reason they haven't heard of it is because until very recently, no one was able to fix it. So we'll get into that in a little bit, but that's an introduction to what is elastin and why it is so important for all of us.
Brilliant. And yeah, like we said before we came on, we're going to explore the whole world of elastin in depth. But yeah, like with all my guests, I'd like to learn a little bit about, who you are, Douglas, a bit of your background and some of the key events that got you interested in this particular topic.
It was a long and winding road, Richard. So this road started more than 35 years ago for me. There were two things that came in parallel in my life, and they came together with this work on hidden stress and elastin. So the deeply personal part of it was when my father died of heart disease. And I also learned that heart disease doesn't really run in our family. It kind of gallops. So a lot of my ancestors had heart disease as well. But no one could really explain well to me exactly what heart disease was and what it is that kills people and how this thing actually gets started. You always hear, about the cholesterol buildup in your arteries. But what comes before that? What is triggering that gummy buildup where the blood flows in your arteries? What's happening there? And I never got a satisfactory answer for that. And especially, there is one thing that causes hardening of the arteries, and that's something called calcification. So that's when basically calcium and phosphate come together to form calcium phosphate, and that stuff builds up in your arteries. And we'll come back to this in a bit, because the great discovery was how this calcification occurs. So my dad had this gummy buildup in his arteries and this hardening of the arteries that almost all of us get as we get older. And the typical explanations just didn't satisfy me. So that was the personal side of it. So I started looking into this in some depth many years ago. Now, on the professional side, as you mentioned, I've worked for the past 30 years on creating healthy products and working with companies and governments and NGOs to completely change the way that we make products. A lot of the mantra that you hear today is that, we have to reduce the negative impact of our activities on the environment. Oh, humans are basically bad for the environment, and we have to reduce our negative impact. Well, actually, a team of us about 30 years ago started saying, wait a minute, humans are not necessarily bad for the environment. Maybe we're just looking at a problem of bad design. And what we started doing was we developed a methodology that talked about not how to reduce the negative impacts, but how to improve the positive impacts. So how can you make products that actually have a net positive impact on people and the environment? And this completely changes the way that you approach making products. And we proved it time and time again. Everything from the ink on a Carlsberg bottle label, because green is the most toxic color, oddly enough,
Right.
to living in where we spend 85% of our lives, which is inside buildings and creating healthy buildings, and everything in between, including carpets that clean the air instead of just carpets that are recyclable. So the whole approach was to develop products that support human health. And by doing that, you create a product that has a net positive environmental effect. Now, how does that relate to heart disease? Well, actually, it's very, very simple. A lot of the drugs that we're using today have a lot of side effects on people and on the environment. A lot of them are excreted, for example, into the environment, and they're causing all kinds of problems. And it's not just heart drugs. It's cancer drugs, it's birth control, you name it.
Yeah.
And really 90% of the drug gets excreted. So you want to make sure that those drugs are actually biocompatible. They're compatible with the environment that they're excreted into, including you, including us.
Yes.
And so we worked very hard to get the attention of the pharmaceuticals companies to say, how about changing the way that you analyze your products? Not just talking about toxicity to humans, but also talking about how that product can be beneficial and be compatible with the environment. And that was the toughest thing of all, was dealing with the pharma companies on this. So those two things started to come together, because I wanted to see how we could develop innovative, healthy drugs that prevent and reverse the effects of cardiovascular disease. And that brought it's called environmental health, oddly enough, which is actually a discipline.
Yeah.
And that's what I did. While we were doing these healthy buildings and all this other stuff, I kept on looking into heart disease. So that's sort of my personal story, how I came to it. There's a lot more as we get through this, because I ran into some really brilliant people. One thing that I just might add is that the methodology we developed actually has won more than 7 international awards and is recognized by a lot of the environmental agencies around the world as being one of the most important methodologies for improving the environmental and health qualities of products. So it's been quite successful. It's called the Cradle to Cradle Design Protocol. And it was developed primarily by Professor Michael Braungart, along with an architect, William McDonough. And I was there at the beginning working with them, proving all of this stuff out. I managed the Institute for a while, and I've been consulting with them ever since. So, but we've also dealt with governments like, we have an extensive relationship with the government of Luxembourg. We just worked with them for the past 5 years to develop the world's first standard that describes the environmental and health qualities of products globally. There's dozens and dozens and dozens of certifications that show this, but no global standard that shows how to digitally recognize in a standardized way the environmental health qualities of products. And that was just passed, actually, by the International Standards Organization a few months ago, and is now an international standard. So, you can see this direction towards combining health with beneficial products.
Right. And so this, you've clearly got a fascination with nature, if you like, including within the body, outside the body, and how we operate within it. And so your father presumably dies of heart disease, and that gives you this motivation to look more closely into this. And where along the way do you discover Elastin?
Yeah. Okay. So here's how the story went. The first book I wrote was called Our Molecular Future: How Nanotechnology, Genetics, Robotics, and Artificial Intelligence will transform our world. And that was in 2002. And while I was doing the research on that book, I came across an inventor who had also shared this concern over what are the true causes of cardiovascular disease. And he actually is he's a doctor of homeopathy, and also, most importantly, a nurse practitioner who had operated in emergency rooms watching people die of heart attacks for years and years and years. And when he looked at the drugs that they were taking, he realized that almost all the drugs, the heart drugs that we were taking, without exception, are just designed to keep us going. They're not designed to prevent or reverse the condition, which is why heart disease is still the biggest killer and biggest disabler around the world, and costs $1.5 trillion a year to treat. And so he actually started looking at Nutraceuticals, supplements, as a way to prevent this. And he had heard of something called chelation therapy, which at the time was, very controversial, still is somewhat today. But chelation therapy is basically this infusion of what's known as a chelator. And a chelator is something that actually chemically grabs heavy metals or metals from your tissue, and then you pee it out. Okay. And one of the chemicals is known as EDTA. It's used around the world. So for EDTA chelation therapy. Well, he tried this with his patients because it was being used, quite extensively then, and still is. But he found that after, he stopped it after a while, the patients just reverted. And so he surmised that there was much more going on there in the arteries, and he started using a combination of nutraceuticals that actually reduced inflammation, which is really important, as well as improving the health of the artery, as well as chelating calcium, actually this calcium phosphate that I talked about earlier, out of the wall of the artery. And now you have to get into, okay, why would you be doing that? Why would you be chelating calcium phosphate out of the wall of the artery? And also, these calcium bits are found in the plaque that are actually build up in the artery. Well, that actually remained a mystery. All we knew was that this calcification was starting in the wall of the artery. Sometimes it started with this plaque, but the key thing is it was hardening the arteries. So normally your arteries expand and contract to help the heart pump blood through your body. And the problem is that as you age, the arteries get harder, and so they can't do that anymore, and they start doing this, and that's what leads to high blood pressure. So he started targeting that with this combination of nutraceuticals that I won't even go into right now. And this combination of the nutraceuticals and the chelator. And he started finding that his patients were improving. And this product was actually something called Nanobac TX. And I was asked to become involved because I decided after doing our molecular future to look more seriously into this, because I concluded after looking at all these molecular technologies that the most important thing was technologies that would significantly improve quality and length of life. And that's why I became interested in the work that this guy, whose name is Dr. Gary Mazot, was doing, because this was something that was very different from any of the conventional therapies. And it was also directed at what he identified, along with some scientists, as infection. Now, why is that important? Because actually, it used to be thought that blood is free, healthy blood is free from infection. Well, now we know that nothing could be further from the truth, that actually there are a lot of bacteria and viruses kicking around your bloodstream and your circulatory system. And most of these are quite benign, but a few of them are really bad for you, and they don't show up on conventional tests. Things like chlamydia, and for example, the bacterium that causes stomach ulcers, Helicobacter pylori. And a lot of these will start in your gut and then move through the rest of your arterial system. But they won't be detected because they're at very low levels. And so unless a doctor really knows that that's the thing that they're looking for, it won't show up on a standard blood test. So here we had what was the beginning of a story of how this hardening of the arteries was beginning to happen, and it was certainly a large part due to this calcification. Traditionally, it was thought that calcification came along much later in life, but now we know for a fact, after work has been done at Harvard University, for example, that it starts very young in life. So we started working on this nutraceutical, and started actually to then go to the FDA, to the regulators, and ask for approval. And that's when the trouble started, because getting a nutraceutical approved by the regulatory authorities is a very expensive proposition. And most nutraceuticals manufacturers simply don't have the resources to do these very, very expensive clinical trials. And so what basically happened was that these guys were out of money. We had an investor who put $15 million into this, and then we ran out of funds. And so I actually then had to withdraw from that whole exercise, and I had to move forward with the other environmental products that we were working on. And that happened between like 2004 and 2010, that whole sequence. Then 5 years later, in 2015, I had kept a watch on everything that was going on with calcification, et cetera, et cetera. And I came across a publication by a scientist by the name of Dr. Vivahari. And he had discovered why we calcify. And that discovery was that the elastic fiber in your body does two things. The first thing is, around the age of 30, your body stops producing it. And the second thing is, because of that, it starts to degrade. And when it starts to degrade, it sends out a help me signal. Help, help, I'm being injured, right? And so the cells around it emit these inflammatory substances. Guess what? Inflammation.
Uh-huh.
Now, a lot of people have heard that chronic inflammation is one of the major triggers for aging. So
Right.
all of this started to make a lot of sense. So the elastin fiber, first of all, your body stops making it. So the remaining elastin fiber, which is designed to last a very long time, like 70 years half-life in your body, gets these little chinks kicked off of it due to all kinds of things. Everything from solar radiation to bad diet to heavy metals to infection. So that's important to understand, is that it's multifactorial. So all of these factors start knocking the chinks off of this elastin fiber, and the body responds with this chronic inflammation, which explains a lot about why so many of us have chronic inflammation as we age. But something else happens. After a while, the body goes to plan B. And plan B is, well, okay, the inflammation didn't fix it because now I've got this vicious cycle going, of inflammation and injury. So I'm going to wall it off. Now, I'm going to wall it off with this really hard stuff called calcium phosphate. Now, the body, that's a very healthy response by the body to injury, because just for an example, many, many years ago, I went skiing and I froze my earlobes, and they were injured. And so the body actually took the dead tissue and calcified it and eventually pushed it out of my earlobe. It just came out about 2 years later. So there is a function for this calcification to to surround things and then get them out of the body. Well, unfortunately, the body tries to do this with your whole arterial system. And that doesn't work very well. And guess what? So you get this calcification going exactly to the source of the damaged elastin fiber. And it hardens it. And you end up with hardening of the arteries. So now we see this much bigger picture of this injury created to the elastin fiber, injuries caused by everything from infection to bad diet to radiation to repetitive stress injuries. The inflammatory response becoming chronic and failing, and then the body trying to wall off this damage. And I just want to show you a picture of what happens over time. So these two pictures are of elastin fiber. And on this side, this picture shows elastin fiber in a 6-year-old. And this nasty picture with everything all degraded and
like
hardened
frayed rope
is in a 90-year-old. That is happening in all of us. This is not like an individual disease. This is happening to every single one of us. And so now you can see this big picture. And that filled in a lot of gaps for me in understanding what I'd been trying to understand for the past, by then, the past 25 years, is why does heart disease get started? And it turns out that degraded elastin is a really big factor in this. Of course, it's not the only factor. There's all kinds of other stuff, but chronic inflammation is a big problem in heart disease. And now we understand a lot of why there's so much of it as this elastin degrades. So I'm going to stop there for a moment because we'll get into the therapies in a moment. But that was my journey. That was my pathway to discovery. And, it mostly came from writing about this stuff, then getting involved with a company, the company failing because it was running out of money, and then discovering why that particular therapy was having some effect, because the Neutraceuticals that they were using were actually partially protecting elastin fiber and preventing some of this hardening. That was not the therapy that was used by Dr. Vivahari, and we'll get into that in a moment.
Right. Yeah. Well, wow. I mean, you've just given me so much more new knowledge, I'm sure, for a lot of our listeners about this whole process of hardening of the walls. I mean, most of us have heard of hardening of the walls, but had no idea of the subtleties you've just described in terms of the mechanics. So
it was a pathway to discovery for me too. I had no clue about elastin when I first wrote this book called The Calcium Bomb, which was the second book, all about calcification. Elastin is mentioned nowhere in the book. So they're bad on me, but no one else was looking at it either, despite the fact that there are thousands of scientific papers about elastin by now.
Right. But people had not been making this link up until when you discovered this, right?
Yeah, well, no. The link was when Dr. Vivahari was able to, in lab animals, actually reverse this process of calcification and hardening of the arteries. Really, really remarkable what he did. So now I guess we can get into that.
That begs the question. Okay, so we've discovered the culprit. How do we now reverse this? Yeah, that's it.
Right. So there's two things. The first thing is you have to free up the elastin because it's calcified. Okay. And there's either fibrosis or calcification. And
what's the difference between those?
Well, fibrosis is basically just the buildup of these fibers, excess collagen fibers, and combined with the degradation of elastin and the deposition of partially formed elastin. Because what's happening is that your body is still creating the building blocks, but after the age of 30, it stops putting them together. So you've got all these partially formed tendrils of incomplete elastin running around your body, which is also causing this chronic inflammation. And so the combination of this fibrosis and the calcification is what causes this hardening of the arteries. And so the first thing you need to do is you need to get rid of the calcification. And that's what Dr. Vivahari proved. He used the same EDTA that Dr. Mazot had been using and thousands of other holistic physicians and integrative cardiologists have been using in chelation. But
what's EDTA? What's that?
EDTA, that's correct. Yeah. And
what is it?
Well, EDTA is this chelator, and it's an acronym for a very, very long chemical name that no one will remember. But everybody can look it up. It's just simply, it's best to know. And EDTA is, by the way, not the only chelator. There's other chemicals that go by acronyms of DDPA and things like that. And there are actually also some natural chelators that are in our foods. Your body actually can get rid of some calcification through enzyme activity, but clearly it's not enough. So back to Dr. Vivahari's discovery. So the reason he found this was because he was researching heart valves. And what was happening was that, a lot of people have to have their heart valves replaced because one side of the heart valve calcifies. And oddly enough, the other side doesn't. So Dr. Vivahari was trying to understand, why is it that one side calcifies and the other side doesn't? And after some investigation, he realized that the side that calcified had a much higher elastin fiber content. And he surmised that was linked to the calcification. And so he started looking around for chemicals and drugs that would actually, get rid of that problem. And he ended up trying EDTA, and it worked. But the problem is, when you shotgun the body with EDTA, it's an excruciatingly slow process. And so it takes sometimes maybe years for this to happen. Like, for example, I took this nutraceutical that Dr. Mazot, earlier had developed. I took it for about, 18 months. And my physician discovered that, he had discovered I had a lump in my carotid artery. It was a small one. It was just it wasn't a big blockage or anything. But what really amazed him was after 18 months, that little lump had actually subsided. And he said he'd never seen that. Never. He just hadn't seen it in his practice. And that convinced me. But, it takes a long time to do that. And when you start to do that in the whole body, it takes even longer. Having said that, I just want to emphasize that this nutraceutical called Nanobac TX, in my view, and I have no commercial interest in the product whatsoever, I'm not participating in it, it does work. It works to improve cardiovascular health, and it works to reverse the effects of calcification, even though they can't claim that because the regulators come after them if they make a medical claim without spending $100 million on a clinical trial, to prove it. So to be clear, this Nanobac TX product is effective, in my view. That's just my personal view. It's backed up by, a number of scientific studies that were done at the time. But Dr. Vivahari was looking for something that would be much more effective, much easier to do in a shorter time. And so he did something that I can only classify as brilliant. And that is, he took the most advanced technology available at the time and a number of technologies and put them together. So what he did was he took the EDTA and he loaded it into a biodegradable nanoparticle, which is like about 50 nanometers wide. This is really, really small. Like it's about 1/100th the width of a human hair And then he attached it to an antibody. Most people have heard about antibodies for treating cancer, for example, and everybody knows the antibodies in our body, go after infection. Our bodies develop antibodies. That's antibody response to COVID, for example, or infection. So that's what antibodies are all about. But antibodies can be engineered to be very specific for a specific thing. And he used an antibody that was specific for damaged elastin fiber. And he actually, along with Dr. Charles Rice, and they're both at Clemson University in South Carolina, they developed this concoction that was a combination of the EDTA loaded into a nanoparticle and targeted to elastin with this elastin-specific antibody. Now, just think about that for a moment. It sounds easy to say,
Right.
but the process of going through and inventing all of that was astonishing. It was absolutely astonishing that he did this. And it was that combination where he was able to prove in these animal models that this calcification could be reversed. So that's the first step, is to get the hardening out. The second step is, as you said, to restore the elastin, to repair it and restore it. Well, an interesting thing is that Dr. Vivahari also discovered, after searching through about hundreds and hundreds of chemicals, there is one naturally derived chemical called pentagalloyl glucose, or PGG for short. Now, PGG is found in all kinds of fruits and vegetables and the bark of trees, and it's found in, for example, the rind of the pomegranate fruit, just to give you an example. So don't throw the rind out anymore. Don't just take the seeds, those nice juicy seeds, but also, you should use the rind. But once again, it had to be concentrated. So, he did that. And the way that he found that out was just by trial and error, but also he had heard that tannins, a category of polyphenol called tannins, which are found in red wine, for example, and grapes, are, have an effect on restoring tissue. And so he tried it, and lo and behold, PGG was the only one that really worked. So he did the same thing. He loaded the PGG into a biodegradable nanoparticle, attached the targeting antibody, and then shot it into a rat. And he was able to show that it repaired the damaged elastin. And when it did that, the body itself started reassembling elastin fiber. So this was actually kickstarting the body's own restoration process. And that meant that after the age of 30, for example, you could actually still repair and restore elastin fiber. Now, just think about that for a moment, right? Every move you make, every breath you take, every time your body pumps blood, all of that degrades after the age of 30 because of this degradation of elastin fiber. Imagine the implications if we were able to maintain that elastin fiber at that quality well into our 70s, 80s, and 90s. What do you think is going to happen to healthy longevity?
Yeah.
Now, we haven't proven that yet, but it stands to logic that this could be a major breakthrough in healthy longevity and prolonging healthy aging. So that was the 1-2 thing. And so first decalcify, and then repair and restore.
Right.
Now, that was one therapy. There was another therapy developed halfway around the world at the University of Sydney in Australia by Professor Tony Weiss and his team. And they did something completely different. They developed a mesh that can be inserted into wounds and on damaged skin. And that mesh they populated with one of the building blocks of elastin fiber, and that is called tropoelastin. So here's how the process works. You have a gene called the elastin gene, the ELN gene, and it controls the whole process of developing this elastin protein. The first thing it does is it creates this tropoelastin. Then the tropoelastin actually is ejected from the cell and combines with a whole bunch of other things in the extracellular matrix outside the cell, including microfibrils and a whole bunch of stuff that I'm not going to explain in a lot of detail here. But the key thing is it's an extremely complex process that, even today, the world's top scientists are still having trouble understanding exactly how it works. But Dr. Weiss's team was able to kickstart that elastin reassembly process by putting the tropoelastin onto this scaffold and then putting the scaffold into a wound or onto damaged skin. And from that, they were able to demonstrate that you could repair wounds without scar tissue. Why is that? Because the reason you get scar tissue is because the elastin is completely destroyed. Stands to reason. And
Right.
so if you have this in the wound, you can actually heal the wound without scarring. And that's what they were able to prove. And so they also started a spin-off company. And I'll get back to the spin-off company that Dr. Vivahari started in a moment, but they started a spin-off company called Elastigen. And Elastigen, several years ago, was sold to a pharma company for the largest buyout of any startup in Australia's history, $250 million. And they were subsequently bought by AbbVie.
I know that. Yeah.
Yeah, AbbVie is a very large pharmaceuticals company. And this is currently now in clinical trials for acne scars and for wound repair. So this is really far along. There's also a third company called Neutaceuticals that combined this PGG with a medical device to deliver it directly to aneurysms in the arteries. And for people who don't know what aneurysms are, they are a bulging of the artery that occurs due to the weakening of the artery wall. And they're very dangerous. And if they burst, they can kill you. And millions of people around the world are living with the daily threat of these aneurysms bursting. And only very risky surgery can really repair this after, the aneurysm gets to a certain size, about 5 millimeters. And so what happened was Nectaro used a catheter device, which is a little wire that goes down into the artery. And they were able to just temporarily, for about 10 minutes, block off part of the artery and deliver this PGG directly to the aneurysm. And what they found was that they could stabilize the aneurysm because they were repairing the artery wall. They were repairing the elastin fiber. And that is now in a phase 2 and 3 clinical trial. We don't know what the results are going to be yet. There's always, stumbling blocks along the way. But the initial results were very promising. You just have to, a lot of therapies, I'll just caution people, fail, at this clinical trial, second and third phase for many, many reasons. It's 95% fail rate of a lot of these therapies. But at the moment, it looks quite encouraging. Now, the reason I'm mentioning all of this is to show it's not just one simple magic bullet, but in fact, scientists around the world, and I'm just mentioning a few, there are like 3 or 4 other companies and scientists that are working on different approaches to elastin fiber. It just so happens that the 3 that I mentioned, Dr. Vivahari's work that led to the elastin, that led to Nectaro's work, and then Dr. Weiss's work, which was done separately. And I'll just give you one example. There is one product that's in the market today already, also from Dr. Vivahari's group, but it's a separate company. It's called Elastin, both the company and the product. And this is a skin cream. And this is designed to actually restore the elastic in your skin. It's available by mail order in the United States right now, but it's very difficult to get outside the US. So I don't know if people can get it in the UK or not, but they can always contact, the company is Elastin. So here we have now, 4 companies, and the one that I didn't mention yet, and just full disclosure here, I helped with Dr. Vivahari to start this company, and it's called Elastin Therapeutics. And Elastin Therapeutics is dedicated to not just using PGG itself, but to using the nanoparticles with EDTA and later with PGG to actually repair and restore the arteries. And we are in preclinical, whereas these other companies that I'm talking about are either already in the market or in clinical. So imagine, there's this really huge story unfolding about repairing elastin fiber. It's a journey in progress. And the funny thing is that hardly anybody has heard about it.
No, exactly.
It's really astonishing. And so for the past 8 years, I've been working with Dr. Vivahari because getting regulatory approval for a very sophisticated combination such as the one that I just mentioned is extremely difficult and extremely expensive. So that's what we're in the process of doing right now. And one of the focuses is on peripheral artery disease, which is the calcification of the arteries in your extremities. And it often leads to amputation and early death due to this hardening that actually prevents blood from getting to your extremities. So that's one of the major fields that we're focusing on.
And so are there implications for arthritis?
Unknown.
Okay.
It could be because arthritis is fundamentally an inflammatory process. There is not much elastin directly at the joint, but there is in the ligaments and tendons, which are very much involved in arthritis. So that hasn't been tried yet, but there are all kinds of possibilities because elastin is in so many different parts of your body. The reason that people have to pee more often when they get older is because the elastin in their bladder wall stiffens. And so that prevents the bladder from expanding and contracting properly. So you can see that there's all kinds of applications here.
Yeah. In terms of my life right now, that would be the biggest win. Having to go to the Lula.
Which is why we're trying to go as fast as possible. And if there are any investors out there listening, we're saying this is the big kahuna. This has vast possibilities, and we need more investment going into this field of elastin reparation and restoration.
Yeah. It's very inspiring to hear all the progress. One question I've got is often with animal models, we extended a rat's life by 50%, or do we have stories like that from any of the trials?
Yeah, sure. But, a rat is not a human.
Sure.
And I have a thing about rats and the whole rodent thing. It's sadly, misdirected in the sense that many of the drugs that are tried in rats, it just simply doesn't apply to humans for 2 reasons. Number one, you're inducing the condition in a rat. Very seldom is it naturally occurring, right? And number 2, the human physiology is very different from a rat, which explains to a large degree why so many surprises show up in phase 2 and phase 3 clinical trials, because the rat is not the human. Now, what's interesting, it's interesting you should mention that, because just recently, the U.S. Food and Drug Administration announced that they are going to be phasing out animal models for some diseases. And they're going to be replacing it with human things called human organoids, which is mini organs, grown in a vat, basically, or on a chip. as well as there's, and this is really interesting, AI. Using AI to predict the model much more accurately. So this is really an earthquake in regulatory. This is the first time the regulators have said, okay, we've always known that these animal models, don't work very well, but we think that replacing this with this much more developed modern technologies of AI and human organoids, we're going to be able to accelerate and improve the safety of these drugs that we develop. So that was a good question that you asked. I might add also, in this case, because we had the experience with Dr. Mizzou's Neutraceuticals, we knew that technically it really was possible to affect calcification in humans. So we didn't just do it in a rat, but Dr. Mizzou actually has done it in thousands and thousands of of patients. And when I say he has done it, a lot of the doctors he works with have actually done it. But again, that evidence was anecdotal, and so you need to go through these clinical trials, and that's what's going on with elastin fiber right now.
Brilliant. Wow. Thank you. Okay, so the next big question I'm sure that's going to be on the mind of some of the listeners is, okay, before these drugs come on the market, what can we do today that can improve our elastin situation?
Well, what you can do is you can slow the degradation of this fiber. And interestingly enough, a lot of the what they call modifiable risk factors. People hear this from their doctor and go, "What's a modifiable risk factor?" A modifiable risk factor is a risk factor that you can modify, that you can change. So everything from diet to exercise, and everything in between is called a modifiable risk factor. Smoking, and that's where we get back to my original story of healthy environments, because we spend 85% of our time in buildings. And one of the biggest problems in buildings is indoor air pollution. It's all these billions and trillions of tiny particulates that you're inhaling. And they are causing a lot of this chronic inflammation and damage in your body. So what we focused on was healthy buildings that actually get rid of these particulates before they get into us, is a big factor in this, as is proper nutrition. Because a lot of foods, for example, are very pro-inflammatory. And again, disclosure here, I've had a plant-based diet for the past 8 years. I have found it to be, very beneficial in the aspects of preventing arterial disease from progressing. And one of the modifiable risk factors is red meat. There's no question about it. It's pro-inflammatory. I know a lot of people will disagree with that. I'm not a dyed-in-the-wool, absolutely, religious vegan. But what people can do to get away from these highly synthesized, highly processed foods is to use whole foods. That is basic foods that, you prepare at home. And a lot of people say, "Oh, I don't have time to do that." That's nonsense. There's lots of cookbooks out there now that will let you do this stuff in 15 minutes to half an hour and prepare, a great meal. So the nutrition part of it is very, very important, as is regular exercise that does not lead to repetitive stress damage. And I just want to emphasize that because, I used to, for example, run about 10 to 15 kilometers every 2 days. And after about 15 years, I was a wreck, because my joints were hurting. This doesn't happen to all people. Some people have got, I don't know, better joints or whatever. My back was all out. And so I stopped running and I started swimming, and all of that went away because it's a non-impact sport that, exercises all parts of your body. It doesn't have to be swimming. It can be yoga, it can be other things, but as you age, these non-impact sports, become much more important. Of course, then again, there's people like my brother who's 78 and still playing squash. but he's about the only one in his whole club who's doing that. So
Right.
yeah, there are exceptions to the rule. So nutrition, exercise, smoking, avoiding inhalation of particles, and that includes, by the way, all these wildfires that are happening around Europe, North America, and all around the world. There's lots of heavy metals in these smoke particles. Wood contains a lot of heavy metals. I haven't talked about heavy metals yet, but they are one of the prime antagonists of elastin and of our health. Heavy metals are bad news. Okay, they trigger heart disease. They are carcinogenic. They cause chronic inflammation, and they interrupt neurological development. So they're especially bad for children. And these heavy metals have recently been designated by the American Heart Association in the United States as the first environmental risk factor for heart disease. So you can see how important it is to protect yourself from these heavy metals. And there are a few dietary things you can learn about on the web quite easily. Just put in, heavy metals and nutrition, and you'll come up with things like vegetable sprouts, broccoli sprouts, for example, or leafy green vegetables that are they kickstart your body's enzyme process that allows your body to chelate these heavy metals and take them out of your body. So that's helpful, but again, because of our industrial society and our agricultural society, all of our grains, for example, take up heavy metals from the soil. So, they're getting into us from all kinds of sources, but there are all of these things you can do with your diet and not exposing yourself to them as much that also are beneficial. And I just want to come back to two things. Low-grade infection and heavy metals are two of the biggest problems. And we need to develop better diagnostics. And doctors need to start testing for more of these low-grade infections because they're not doing it as a matter of course. And the standard blood tests for heavy metals don't work very well because guess what? Heavy metals largely don't reside in your blood. They're in your tissue. And so when you take a blood test, it doesn't show that. It'll give you an inkling, but normally the blood test comes back, yes, you're within an acceptable range. But if you use a chelator and put it into your body, which should only be done, by the way, with a experienced clinician, if you do that for an hour and then you pee out the chelator, you get a completely different story. You get very high levels of these heavy metals coming out. I've done, the test, and it's just absolutely amazing, the difference. And I've seen the test done on others. So we need to get a much better testing regime standardized to start looking at these heavy metals.
Right. So get tested, figure out how much heavy metal you've got.
Figure out the right test. Yeah, look for the right, and that's what I talk about in the book.
Blood test, right? Like,
all the stuff that we've talked about here is described in the book. There's not quite so much on the nutritional side, and here's why. Discovering the Nature of Longevity, the book, is designed to show what's coming down the pipe, what is in clinical trial right now, to greatly extend our healthy longevity. It's not to say that the other things that I talked about are important, but the fact of the matter is, as you know, there are thousands and thousands of books out there on diet, exercise, all of these things. And there's no point in me reinventing the wheel. I say, yes, it's important, but we take this to the next step and say, okay, how can we build on top of that to have these therapies that actually significantly repair and restore our elastin fiber when all the other things don't work? And so the book is about that, and it's about the stories of how Dr. Weiss and Dr. Vivahari and Dr. Rice, how they made these incredible discoveries, and Dr. Mazot, of course, who came along with this nutraceutical so many years ago. It's now been on the market for 25 years. The FDA went after them, but finally dropped all of its objections. And it's really amazing. It's an amazing story of tenacity. And all of that is brought together in Discovering the Nature of Longevity.
Yeah, and the story, I particularly like the story of Vivahari, which we didn't get into in this, but maybe we can save that for people who want to buy the book. And that's a
the short story
fabulous
is
story
that
of
the short
tenacity.
story is that he came from speaking almost no English, graduating, from Pune University in India, to coming over here and ultimately becoming the head of the bioengineering facility at Clemson University. It's just an extraordinary story of brilliance combined with tenacity. He has
Could be
my
a movie,
absolute
right?
full
Yeah.
respect to this guy. He's
Yeah.
really phenomenal. And I also, want to mention he had the brains to put together other people. He brought Dr. Rice into this, and Dr. Rice is a specialist in antibodies. And so he developed this antibody that was specific for damaged elastin. It's just a really amazing story. And maybe, because we're getting to the end, just remember, elastin fiber does this. It expands from a standing length to 8 times its standing length and snaps back billions of times in your lifetime. It is truly the elastic of life, Richard. That's why I call it, restoring the elastic of life. It's extremely important. And I'm so happy that we've been able to do this show because so few people know about this. And it's really important that we develop more interest, more investment, more regulatory approvals to get this done.
Yeah, wonderful. Well, hopefully this has played a part in spreading the awareness of elastin, and will encourage some people to go out and buy your book and dig a bit deeper. Or if they've got some cash and they're looking for exciting opportunities for pharma investments, then
and if they want to learn more, investors want to learn more, they can go to the short name for my site is calcify.com. So it's www.calcify.com, and people can go there. The long name is www.natureoflongevity, all one word, .com. So, and I think that'll also be on your crawler.
Yeah, we'll put the show notes. We'll put the links to both of those sites and directly to the book.
Yep.
Yeah. So it'd be very.
And the book is available on Amazon, also in the UK.
Yeah, great.
And I'm really happy to say that it went to number 1 in 7 categories on Amazon several times over the past year and a half.
Wow. Well, congratulations. I mean, it's a fantastic book, and it's breaking new ground. Nobody else is talking about elastin. Well, that's not true in the way that you are.
There's technical books,
great
but
story.
no book has been written for general audiences that describes this story.
Yeah, and it's very accessible. It's anybody can read it and get their head around it. Yeah. Fabulous. All right. Well, thanks once again, Douglas. It's been just a brilliant conversation. I'm so grateful to have had the chance to talk about this with you, to build my understanding in this area, and I'm inspired. Yeah, I mean, perhaps this could make a significant dent in this condition, heart disease, that so many people suffer from. I mean, my dad didn't die of heart disease; he died with it, but he had to go through the rigmarole of having a stent, and his life was certainly impinged by it.
And the stents plug up.
Yeah.
Yep.
Yeah.
The stents plug up, and there is some evidence that can now be reversed as well. So,
thank you for the work you're doing.
Well, Richard, thank you so much for having me on the show. It's really been delightful, and we should do this again to talk about things like epigenetics and these tiny little particles, trillions of them running around your body, called exosomes and extracellular vesicles. And they're all part of the story as well, and they're in the book. But each of them is definitely worth an episode.
Because we didn't get into exploding vesicles, which we could have done. But
yeah. And you talk about things that people have never heard of. Exosomes are becoming well known, but epigenetics, which means above genetics, most people think their life is dictated to them by their genes. It's not. 70 to 90% of all diseases are triggered by the environmental factors that turn your genes on and off. And that's called epigenetics. And that's for another show.
Brilliant. Okay. Yes. All right. Well, thanks again. Thanks again, Douglas. It's been fantastic. Thank you. And we'll put all the links in the show description.